All right, so today we're going to start chapter 6, and we are going to look at chemical bonding today. All right, so we have a little bit of background here. So we know that most of the elements on the periodic table, so the elements that are not noble gases, they are not stable atoms. And the reason why they're not stable is because they don't have a full set of valence electrons. So elements want to be stable, and the way they do that is but they do that by bonding with other atoms. And this also decreases their potential energy. And so elements can bond either by gaining electrons, losing electrons, or sharing electrons. And so that's really our topic today, is looking at the different types of bonding. So let's start with ionic. Now, in order to have an ionic bond, you have to have a metal combining with a nonmetal. And we need to build off of what we know in chapter 5. So we know from chapter 5 that metals have a low ionization energy, so they give up electrons easily, so they form our cations. And we know that nonmetals have a high electron affinity, so they gain electrons, and so they form our anions. So what happens in an ionic bond is that you have a cation that transfers its electrons to the anion. So the word transfer here is kind of the key idea behind ionic bonding. All right, the second classification of chemical bonds that we're going to talk about today is covalent. And in covalent bonding, we're looking at the sharing of electrons. Now, there are two types of covalent bonds. All right, so type 1 is called a nonpolar covalent bond. And in a nonpolar covalent bond, you have two atoms that are bonded together that have similar electronegativities. And for that reason, they have an equal attraction for that pair of electrons. So these two atoms are going to share equally. The second type is called a polar covalent bond. And in a polar covalent bond, you have two elements that have slightly different electronegativity values. And for this reason, they have an unequal sharing of electrons. So the more electronegative element has the greater affinity for electrons, so it's going to be pulling those electrons toward it. All right, so obviously I've mentioned the word electronegativity. So we can actually use electronegativity values to determine the type of bond. All right, so if you would take out that periodic table that I've given you, and if it's going to take you a second, go ahead and just pause the video. And on the back side, in the upper left-hand corner, there's a table of electronegativity. So that's what we're going to be using today in class. All right, so we're going to do one row at a time. So the first thing we're going to do is I have two chlorine atoms that are going to be bonded together. And so we want to determine the bond that's going to occur between those two chlorine atoms. So the first thing we're going to do is look up the electronegativity value for each of those chlorines. And so if you look at the table, it has a value of 3. And then we're calculating electronegativity difference. So we're going to subtract the two values. Now, in this case, it doesn't matter the order in which we put the electronegativity values, but just to kind of as a reference, you're always subtracting the smaller from the larger. You should always have a positive electronegativity difference. So if my difference in electronegativity, so that's what this little triangle stands for, is difference N, and we know that En is the abbreviation for electronegativity. If the value difference is between 0 to 0.3, which is what this falls into, then this would be a non-polar covalent bond. Okay, now at some point we're going to have a quiz. Just kind of as a reference, you'll be given the table of electronegativities, but you will be responsible for memorizing the electronegativity differences and what bond it corresponds to. All right, let's look at my second example. So again, we're going to go back to that table of electronegativities. We already know that chlorine is 3.0. And then we're going to look up hydrogen, and it is 2.1. And we're going to subtract, again, always the smaller from the larger. Okay, so let's talk about our next category. So if the electronegativity difference falls within the range of, it has to be greater than 0.3, to 1.7, then this is considered to be a polar covalent bond. Okay, so again, you're responsible for knowing these electronegativity differences categories. All right, so if I look back, chlorine is the more electronegative element. It's going to be pulling those electrons toward it. So that's why there's that unequal sharing of electrons. All right, the last one is between sodium and chlorine. So again, we know chlorines. We're going to look up sodium in the table, and we get 0.9. We are going to subtract, again, always the smaller from the larger. So in this category, if the electronegativity difference is greater than 1.7, then this is going to be an ionic bond. So again, we're responsible for knowing electronegativity ranges for each bond type. All right, so in this case, if I have an ionic bond, there is going to be a transfer of electrons. So if I'm looking at my table, I can see that sodium is my metal because it's to the left of my stair-step line. Chlorine is my nonmetal. And so what's happening here is that sodium is going to give away its electrons to chlorine.